Chapter 1.3.3 Runtime Class. Kubernetes v1.20 introduces the Runtime Class resource and runtime selection mechanism, allowing for the customization of container runtime configurations used to run a pod's containers. This feature enables users to specify the container runtime configuration for each pod. Motivation. Runtime Class allows you to set different container runtime configurations for various pods, balancing performance and security. For pods requiring high information security assurance, you can schedule them to run in a container runtime using hardware virtualization for extra isolation. This may incur additional overhead, but increases security. Additionally, you can use Runtime Class to run pods with the same container runtime, but with different configurations. This flexibility allows for customization based on the specific needs of each workload. Setup. Runtime Class allows for the configuration of Container Runtime Interface (CRI) implementations on nodes, which is dependent on the runtime being used. The configurations must have a corresponding handler name and be referenced by the Runtime Class. By default, Runtime Class assumes a homogeneous node configuration, but support for heterogeneous node configurations can be implemented through scheduling. For each configuration, a corresponding Runtime Class object must be created with a valid DNS label name. It is recommended that write operations for Runtime Class be restricted to the cluster administrator. The Runtime Class resource only has two significant fields: the Runtime Class name and the handler. See the documentation for your specific CRI implementation for detailed instructions on how to configure Runtime Class. Usage. The text explains how to configure and use runtime classes in a Kubernetes cluster. Once runtime classes are set up, they can be specified in a pod spec using the Runtime Class name field. If the specified runtime class does not exist or cannot be run by the Container Runtime Interface (CRI), the pod will enter the failed terminal phase. If no runtime class name is specified, the default runtime handler will be used. Configuration for containerd and CRI runtimes is done in the ec/containeredconfig.toml and /ec/cryo.conf files respectively, with valid handlers specified in the configuration files. For more information, refer to the respective documentation for container.io configuration. Scheduling. Kubernetes v1.16 introduces the ability to set constraints for pods using a specific runtime class, ensuring they are scheduled on nodes that support it. This is done by specifying the scheduling field in the runtime class. If scheduling is not set, it is assumed that the runtime class is supported by all nodes. The runtime class's node selector can be used to select nodes with a common label, ensuring that pods are scheduled on the correct nodes. Tolerations can also be added to the runtime class to allow pods to run on tainted nodes. In Kubernetes v1.24, the stable release now allows for the specification of overhead resources associated with running a pod. By declaring overhead in the runtime class's overhead field, the cluster and scheduler can account for these resources when making decisions about pods and resources.